All right, so this is section 3.4, operating with scientific notation. So we're going to add, subtract, multiply, and divide in scientific notation today. Okay, so this first problem is a chart that's really tiny on your notes outline, but you can look up here and I'll also give you the information. So this is asking about how many times greater is the mass of Jupiter than the mass of Earth? Okay, and then you're going to write your answer in scientific notation. So how many times greater? So if I were to tell you that, if I were to talk about weight, okay, if I say this person weighs 300 pounds and this person weighs 100 pounds, how many times greater does that person weigh? 3 times. So we did that by dividing, even if you didn't really realize you were dividing that. So we are going to divide Jupiter divided by Earth to figure out how many times greater is Jupiter than Earth. Okay? So we're going to write, this is really tiny on your paper, but Jupiter is 1.89 times 10 to the 27th, the mass, and then Earth's mass is 5.97 times 10 to the 24th. Okay, so how we do this is look at this like two different problems. So we're actually going to divide our numbers. So take 1.87 divided by 5.97 and actually calculate that. So divide your two numbers, 1.87 divided by 5.97. Yep, 1.89. That's what I meant. And what do you get when you divide? 0.31658, so we could round up maybe to 66. And then how do you divide exponents if they have the same base? Subtract them. So we're going to take the 27 minus the 24 and get 10 to the third. Okay, so now you need to check and see, is your number in proper scientific notation? So in order to be in proper scientific notation, we have to have one number in front of the decimal. In this case, we have no numbers in front of the decimal, right? So it's not. So we need to fix it. So we need to move the decimal right one. So that would be 3.166. And then because we moved it to the right one, we have to balance this. So if I move to the right one here, my 10 to the third needs to take away 1. So what would that become? 10 to the second. So I have to balance it out. If I add 1 on the left, I got to take away 1 on the right. Okay? Okay, so the next problem. Pluto was demoted from a planet to a dwarf planet in 2006, in part because of its small size. The mass of Pluto is about 1.3 times 10 to the 22nd kilograms. About how many times smaller is Pluto's mass than Earth's mass? So we're going to divide again. We're going to divide Earth divided by Pluto. So Earth on your chart says it's 5.97 times 10 to the 24th, and we're going to divide that by Pluto's size. So that's 1.3 times 10 to the 22nd. So again, divide your numbers first. Yes.
So I'm thinking like on the multiplication sign, are you supposed to use an X or?
Yeah, you're supposed to use an X with scientific notation. So otherwise, I told you guys we don't really use X anymore for multiply because in algebra X is a variable. But scientific notation is like the only scenario where you use X still. It is an X in the middle. That means times. So what is 5.97 divided by 1.3?
4.59230769.
Okay, I'm gonna cut it off at 3 decimals. And then I need to do what with my exponents? Subtract. So 10 to the 20, not 22nd, 10 to the second. Okay, and then check, is this in proper scientific notation?
Yes.
Yes, there's only one number in front of the decimal, so you are good to go. Okay. The very next problem, the mass of the sun is approximately 3.1 times 10 to the 6 times greater than the mass of Mars. Find the mass of the sun. So your chart gives you the mass of Mars, and I'll write that down. But what are we going to do with those two numbers? You're going to multiply them. It's saying that it's times greater, so multiply. So Mars would equal 3.1 times 10 to the 6 times the mass of the sun, and the sun is 6.42 times 10 to the 23rd. So we're going to multiply those. I got that number off of the chart at the very beginning. So multiplying is very similar to division. So I multiply my numbers first. And then how do you multiply exponents? You add them. So 3.1 times 6.42. Anybody get it? Okay. I got 19.902 times 10, and then I need to add my exponents. So 10 to the what? 10 to the 29th. Okay, and is this in proper scientific notation?
No.
No, I need to move my decimal one place to the left, so I need to balance it on the right. So if I took away 1, I have to add 1. So this will become 10 to the 30th. And this will become 1.9902. Okay. All right, the mass of Venus is about 66 times the mass of the moon. What is the mass of the moon? So 66 times the mass of the moon equals Venus. And on the chart, it says that Venus is 4.87 times 10 to the 24th.
Wouldn't it be easier to do like find out what 10 to the 24th is and multiply that by 4.87 and times that by 66?
You could, but that would be like a number that's 26 digits long or 25 digits long, which would be really big, yeah. So here, if this were just a regular variable right here, how would I get it by itself? Divide by, I need to divide by 66. So I'm going to divide 4.87 times 10 to the 24th divided by 66. Okay, so 66, how could I put that in scientific notation, or do I need to?
Not supposed to.
Huh? So it would be 6.6 times 10 to the what? How many times did you move your decimal?
1.
1 time, so this would be a 1. 6.6 times 10 to the 1. So then I'm going to divide 4.87 divided by 6.6. What'd you get?
32.1.2.
I got
0.7377.
Yeah, that's what I got. 0.7378. And then I need to subtract my exponents.
23.
So 10 to the 23 power.
And you need to move the decimal to the right one. And then
Yes.
you will subtract one, and that'll be 22.
Yes. So you have to balance it out and put it in scientific notation.
Wait.
Okay. The next one, the mass of the moon is about 7.35 times 10 to the 22nd power. Find the approximate combined mass of Earth and its moon. How would you find a combined mass? You would add them, because combined means add. So we are going to add the moon plus Earth. So 7.35 times 10 to the 22nd. Plus Earth, which is 5.97 times 10 to the 24th. Okay, addition is a little bit different. So in order to do addition, you have to have a common exponent. So I think it's easier to go to the bigger exponent. So I would make them both 10 to the 24th. So I have to balance this out. So if I make this 10 to the 24th,
That'll become 73.5.
I am adding 2, so I have to take away 2 from the left.
So
So I have to go 2 times,
Zero.
so 0.0735. Plus my Earth's mass. Okay, so how you do this is you add your numbers and then you keep your exponents the same. It's very similar to adding fractions. So my answer is still going to have times 10 to the 24th, but I need to add my 2 numbers up. Okay, so what do you get?
740.
435. 6.0435. And is that in correct scientific notation?
Yes.
Yes. Okay. Next one. How much greater is the mass of Neptune than the mass of Venus? So if I say that this person weighs 500 pounds and this person weighs 200 pounds, how much greater do they weigh? 300, right? You would subtract. So we need to subtract Neptune minus Venus. So Neptune is, on your chart, it says 1.02 times 10 to the 26. And Venus is 4.87 times 10 to the 24. Okay, so I have to get a common exponent to subtract. So again, I would make this 10 to the 24th go up to the 26.
0.0487.
So if I added 2, I have to take away 2. So 0.0487.
How's it taken away to?
Moving left 2, like taking away 2 digits, 2 placeholders.
Because if you make this number bigger, okay, like if you get this 0, make it right there, make it 48. You make this one smaller. This one smaller.
Okay, so I need to subtract my numbers. 1.02 minus 0.0487. 0.9 times 10 to the 26. Okay, and is that in proper scientific notation? No, so I need to move to the right one. And since I moved to the right one, what happens with the 26? It gets smaller, so smaller by 1. Okay, one more problem. Or 2 more. You have 2 more in your notes, not like. Okay, the water in Mono Lake, California was used for residents of LA. As a result, the lake's volume in acre per feet dropped from 4.3 times 10 to the 7th to 2.1 times 10 to the 7th from 1941 to 1982. After becoming protected, the lake increased in volume by 5.0 times 10 to the 6th over the next 20 years. What's the volume in 2002? Okay, so this would be 1941. This would be 1982. Is the 1941 number even relevant to answer the question? That's not even needed. Okay, so then I need to take my value in 1982 and add it to my volume that it increased by. So I need to take 5.0 times 10 to the 6th plus 2.1 times 10 to the 7th. So I need to first get my common exponents. So I would go up to 7 here. So 10 to the 7th, and what happens with my 5?
Goes 0.5.
It goes to 0.5, and then plus 2.1 times 10 to the 7th. So I'm going to add my 2 numbers.
2.6.
So 2.6 times 10 to the 7th.
That's it.
And is that in proper scientific notation? It is, so I do not need to change anything. Okay. On the very last one, I want you to go through and do this. Remember to get a common exponent. So pause your video and do this problem. All right, so I would choose to raise this to 10 to the 34th, I mean.
31st.
34th, and then so I had to add 2. So I'm going to take away 2 right here. So right now your decimal is after the 9. So I need to move it to be after the 4. So 4.89 times 10 to the 34 minus 4.7 times 10 to the 34. So 4.89 minus 4.7. 0.19 times 10 to the 34. And is that in proper scientific notation? No, I need to move my decimal 1 time to the right. So 1.9, and if I moved it to the right, what do I do with my exponent?
Add 1.
Take away. Take away 1. So it should be 1.9 times 10 to the 33 power. Okay. Your assignment is page 107 and 108, even 2 through 30.